Hi, this is Algebra 1, Module 3, Lesson 5, Pulling It Together. This is a extension of last lesson, Lesson 4, so we're using the same graphs and we're expanding on it. Allie and Dane work at a water park and have to drain the water at the end of each month for the ride they supervise. So this is the same. Each uses a pump to remove the water from a small pool at the bottom of their ride. The graph below represents the amount of water in Allie's pool, A of x, and Dane's pool, D of x, over time. In this scenario, they decided to work together to drain their pools and created the equation G of x equals A of x plus D of x. So let's answer the following questions about G of x. What does G of x represent? Well, it represents the total water in both of the pools over time. Since it is the addition of A of x and D of x. So A of x means the total of water in Allie's pool. D of x equals the total water in Dane's pool. So if we add them together, we're asking for the total water in both of the pools, depending on the time. So we need to create a graph of G of x on a new set of axes using the graphs of A and x and D of x. So we need to identify G of x, so the equation, and label the scale and axes. So from last time, we know we're counting by 4,000s. So we knew that this mark was at the 24,000, and then this one was 28,000. So we know that we have some information there. We also knew that where they connected was 10 minutes. Both had the same amount of water, 14,000 gallons, at 10 minutes. So, given this information, we should be able to find a few points on our new graph. So just to start with, let's go ahead and find some information here. So we know that if we do A of 0 plus B of 0, we are going to get G of 0, right? Because that's the two of them added. So A's 0 is 28,000. Added to D0, which is 24,000, gives us a total of 52,000. So we know we have the coordinate. So I'm going to set this over here. Let's do this one in a different color. So we know we have the coordinate of 0, 52,000. All right, so another point we know is that one in the center where they're A of 10, where they both equal 10. A of 10 plus D of 10, since we know that point, well, A of 10, we said, was 14,000, plus we said D of 10 was also 14,000. That means G of 10 would equal 28,000. So we have another coordinate. Oh, I did not want to do that. Let's undo. Oh, no, it's not doing what I want here. Just a moment. That back, 14,000. 14,000 equals 28. So over here we said 0, 52,000 and 28, oh no, 10 minutes was 28,000. So being able to have this, we have two coordinates that we can graph. We also can figure out our slope. So let's go ahead and figure out our slope while we're at it. So if we take our y's and subtract them, 52,000 minus 28,000 divided by, say we need 0 minus 10, we are going to equal, well, 52,000 minus 28,000 is 24,000 divided by negative 10, and that equals negative 2,400. So we have a slope of negative 2,400. So given all this information, I'm going to go over to a graph, and I'm going to first start by plotting these 2 points, 0, 52,000, and 10, 28,000. So 0, 52,000. So I've already got my graph set up here. 10, 20, 30, 40, 50, here's 60. So 52 is going to be right in here somewhere. Below 55, but it's a big dot. Or not. Okay, 52 is somewhere in there. And then we're going to have 10 comma 28, which is going to be somewhere about right here. And so I know if I connect these, my line has got to be somewhat straight, be somewhere around here. This is where it'd be great to have a straight line. Ugh, I'm going to undo both of those and make that a little nicer. Okay, so 52. You guys should be doing this with a ruler on your, somewhere in there. Okay, and I hit undo again. All right, let's not do that again. All right, last time, third time's a charm, right? All right, something like that. So this is my graph. And so that is my visual representation of this. So you might want to pause and be able to fill all that in. But I'm going to go back so we can keep going. Okay, so we could have also used our slope when trying to figure out our graph as well on there, but keep this in mind for the next question. All right, so write an equation for the function using the graph you created. Compare this equation to the algebraic representation of finding the sum of the two equations. So when we were doing this, we said the starting point was 52,000, right? That was our total again. And then our slope, a slope of negative 2,400. So given this information, we come up with an equation of, let's do it in blue. So our equation would be g of x equals their starting point, 52,000, minus our slope, because that's what we're repeating each time. So according to our graph, we had the starting point of here, and with our 2 points we found, we have this slope. Let's see how that compares to the algebraic way of finding this. So the algebraic way of finding this would say g of x equals a of x plus b of x. So my a of x was 28,000 minus 1,400x plus my b of x, which is 24,000 minus 1,000x. And so when you simplify this, you want to combine the two numbers together. So 28,000 plus 24,000, well, that's 52,000. thousand. And if I take negative 1400x minus 1000x, so I'm going to go ahead and draw some lines here. So the 52,000 came from the 28,000 plus 24,000 to get me 52,000. So now I want to take the minus 1400x minus 1000x, and I'm going to get, well, negative 1400 minus negative 1000 is negative 2400x. So now I've gotten my x's combined. So it's just like apples and oranges. You can't say I have 3 apples and 4 oranges and I have 7 oranges. No, you have 7 fruits, but you don't have 7 oranges. You have to keep those labels separate. 52,000 gallons of water and negative 2400 slopes or x's. Okay, so use both the graphical. So should these be the same? Yes. Whoa. Let's get rid of that. Try again. So yes, they should be the same. All right. Use both the graphical as well as the algebraic expressions to describe the characteristics of g of x and explain what each characteristic means. So the intercept, domains, range, etc. Well, one thing we haven't figured out is we got our y-intercept, 5,200, but we haven't figured out our x-intercept. So I'm going to figure out the x-intercept up here, and then I'm going to go down below and fill in all my information. So to figure out my x-intercept, I need to have when g of x equals 0. So 0 equals 52,000 minus 2,400x. Well, my first step is to get rid of the 52,000. So I'm actually going to scoot this over a little bit. So if I have a positive 52,000, I want to subtract 52,000 from each side. And those cancel to make. So now I have negative 52,000 equals negative 2,400x. And to get rid of my negative 2,400x, I need to divide by negative 2,400 on both sides. And so that makes x equal, and we can leave it as a fraction, divide both of those by 8, you get 65 thirds, or 21 and 2/3. So it is a 0.6 repeating, so you can't just put 21.7. You need to be accurate. So keep it in fraction form. So 21 and 2/3. All right, so this would be my x-intercept, that 21 and 2/3. So let's go down here, and I'm going to put number 5 on here in a text box. And we're going to just start listing all the different stuff that we need to have for number 5. So number 5, we have, we know our slope. Slope is negative 2,400. So it's decreasing at that rate at 2,400 gallons a minute. Something else we know from this, if we start going in our domain range and all that sort of thing, we said our y-intercept was 0, 52,000. And what that means is that is our initial amount of water, right? Because that's our total we started with. Do doubles on here so they're not getting confused. Let's do x-intercept is, we said 21 and 2/3, comma 0. And what that one means is that's when the pools are drained. The pools are empty at 21 and 2/3 minutes. Domain, we haven't done domain yet. Domain, we said, so domain is the x's, so we go from 0 to 21 and 2/3. So that means it takes 21 and 2/3 minutes to drain the pool. The range is 0 to 52,000 is our y's. That means a full pool, 52,000, and it empties to 0. What else do we need? Minimum and maximum. So our maximum is 52,000 gallons at 0 minutes. And our minimum is, let's see, is 0 gallons at 21 and 2/3 minutes. I think we covered everything. Domain range, we don't really have, it's always decreasing, which we kind of set up here with our slope. So yeah, there we go. It's saying constantly. I'm going to throw in here constantly. Consistently, here we go. Consistently, that's a better word. Consistently. There we go. All right, so that's all the information for number 5. Number 6, explain why adding the two values of the y-intercepts together can be used to find the y-intercept in g of x. Well, it works out pretty well this way because since the y-intercept of each is when x equals 0, that means adding the two y-intercepts, let's be specific, intercepts together. I'm going to put in here as an example, since we're doing a of 0 and b of 0 would give you g of 0, because that follows our equation for the g's y-intercept. It's those, because we're doing inputs, and that's really what g of 0 is adding the two inputs of, we put in the same input in both, and then we're adding the outputs together. So since everything is the same input, it works. So can the similar method be used to find the x-intercepts? Unfortunately, no. Since since the two inputs of each are different, it doesn't work the same. So logically, if you think about it, you can add two amounts of water together, but you can't add the sum of two different amounts of time. So the x values are time, so you can't add 24 minutes and 22 minutes and still get the same output on there. You can add 24 gallons of water and 8 gallons of water and still end up with more gallons of water, and that makes sense, but it doesn't work with this one. So that's it for this one. Thank you for joining us, and we'll see you next time.